All right, so glaciers in the ice ages. Glaciers are cool. Don't get me wrong. No pun intended. But I've always said glaciers, and then we'd end up talking a little bit about ice ages at the end, which I think you guys found the last 3 slides way more interesting than the previous, 27. So then I finally added the word ice ages into the title, and maybe I added a slide or more a couple years ago. But it was still not a whole lot of anything about the ice ages. It was just a couple slides at the end, talked about the relevance to New York State, and that was it. Over the last week, I don't say greatly expanded, but I have significantly expanded the ice ages conversation. And again, hopefully you'll find it interesting. It spans a handful of things, and up through even talking about different humans and whatnot, because we do talk about some geologic time there in the end. So, glaciers. When I have talked about them in here, usually the words that come out of my mouth are mile-high wall of ice right around here and all the way, stretching all the way back to the North Pole. And that's a fine image, okay? That is what we call an ice sheet, all right? But there's another type of glaciers, and those are called alpine glaciers. Alpine is in a mountain. The ice sheets are mostly gone now. South Pole, Antarctica, obviously has some ice on it. If you pay any attention to the news, you know that is breaking off and floating away. People are getting concerned about that. The North Pole. Again, if you pay attention to stuff like that, you might know that they're talking about now we can bring shipping through there. And you might have heard about the polar bears drowning and all that stuff. That was a good 5 years ago. Polar bears are still drowning, but they, again, now they're talking about other benefits for shipping. Don't have to go around North America anymore. Well, they weren't going around. I think they were using the St. Lawrence and going that way. But it's melting away. We've mentioned, I think, also the difference between ice at the North Pole and ice at the South Pole. Ice at the North Pole is not on land. That's like ice in your drink. When that melts, it doesn't really change sea level. It makes less ice and more polar bears drown. But it doesn't affect sea level that much. You can have all that ice in your glass you want, fill it up with iced tea, and let it sit there. It's not going to overflow when it melts, right? Why? Because that ice is already taking up space, and as we mentioned, solid form, crystalline form of water takes up more space. Not a lot, but more space than liquid does. So if anything, the water level will go down a little bit. But ice on land, when that stuff's breaking off of Antarctica, that's the stuff you want to worry about, because that will add to the volume. That's above sea level, it's above the water level, however you want to say it, even though it's hanging off in sheets. Okay, then it can break off. It's not like Antarctica is breaking apart, right? It's these overhangs that are breaking off. But they weren't arguably in the water, so they will add to the volume when they melt. So we hear all about that crap. But you don't hear so much about the alpine ones. If I mentioned it at all, we talked maybe briefly about, again, how they're declining. And India comes to mind all the time. How in the Himalayas, they're seeing less and less constant ice. They rely on that as a source of fresh water when the melt comes. And we're going to start seeing, water issues there. Those are the alpine ones. You look at as you're going to see in a minute, some mountains, no matter where you are in the world, could be the warmest place on the planet. If the mountain is high enough, there's going to be ice there. India and cold doesn't necessarily go in the same thought sentence, right? But if you go up high enough, you've got mountains that are there. So keep that stuff in mind as we're talking about this as well, not just those mile-high walls of ice. That's where this conversation is going to end on Thursday. But, and I'll touch on it a few times in the meantime. So, that being said, you've been staring at a glacier for however many minutes I've been talking. Let's say 7 minutes now. You see that white river in the middle there? That white river, and there's a little one behind it. Oh, that's a glacier. The scale on these slides is abysmal. I'll be honest. It is really hard to tell how big any of this is, other than I'm going to tell you it's freaking huge. Okay? If you were walking on that glacier, you would not even be that. I'm seeing a spot over here. I'm going to attempt to point to it with my mouse. You would probably not even be that spot. Maybe you'd be that spot. All right, this is huge. They could flow. We're used to thinking, okay, a glacier is going to slide down a hill. That's true. The warmth of the earth kind of lubricates up the bottom of the glacier. It melts a little bit. It slides down the hill. Yes. But there's also another aspect to it, and we're going to see a couple slides about it. They kind of beat it into the ground a little more than necessary, I think. And I'm supporting that, I suppose, by showing you the slides. But kind of like you guys are the slime generation. You grew up making, the borax and the whatever the heck goes into it. If you kind of imagine that stuff rolling down a slope, right? It sort of overturns on itself. There's some of that going on in here as well. It's not just, that's how it grows. So it gets fed back here, and then it's going to flow down as it grows. It's going to push. So it's not just one hunk of ice sliding down a slope. Here's sort of a zoom in on the same thing we were just looking at. And again, scale is tough. One of your classmates that's not here today was talking the other day about how he's climbed a handful of the high peaks and so on and so forth. This is not doable for someone like that even. You see this snaking off again through there. These are big things. And if this were to melt out, that would be a substantially even deeper valley. You're going to hear about glacial valleys that carve U-shaped valleys. They get so excited about the U-shaped valleys. All right. The difference is streams carve a V, and glaciers, because of the shape of the ice, so on and so forth, they carve a U. The problem is, in practice, that, again, streams have floodplains on either side. We haven't talked about streams in here too much, but you're familiar with the idea of a floodplain. That tends to get rid of a lot of the V shaping. These things, once they drain out, usually they get a river in them. So you get a river in this valley in the first place. My point being is they don't look a whole heck of a lot different from each other. You'll see some pictures a little later. So this is carving a valley. This is a huge amount of ice. You guys, we didn't talk about rocks in here that much, but be it granite or sandstone, i.e. something really hard versus something not so hard, it doesn't matter. It's still going to cut through it. Okay, given enough time and whatever, this is just an immeasurable force. I talked about this a moment or two ago. What we're looking at here is latitude. Okay, you got the equator in the center, and you go north. I don't know which side is north. That side's north for some strange reason. North and then south. The point being, you could be at the equator and still have permanent snow if you have a high enough mountain. So this is showing you altitude and elevation. Go to Hawaii, find a snow-capped peak there, even in July kind of thing. This is different than snowing. Someone just posted a picture yesterday, one of the local weathermen. Somewhere northern New York, there was a blizzard up there. I mean, it was just crazy snow. It was up above 2,000 feet. And,
We're not talking about that. We're talking about all year round. It's there. Permanent snow. Mount Fuji's one they take a lot of pictures of, right? Japan, again, not a place that you think of as being particularly chilly, but the top of Mount Fuji's always covered. So, for now. There's probably way too many slides about this as well. So glacial ice, first and foremost, again, we need to get a buildup of snow for a very long period of time. Okay. One of the things you're going to hear about in the end is we're going to go back and talk about, 10,000 years ago, 100,000 years ago. They even get to talking about a billion years ago. Now, we don't have snow from a billion years ago. They're looking at deposits and stuff like that. But some of this more recent stuff, all right, you've seen an ice cube. There's little bubbles in it. That is some of your house air or your freezer air trapped in those ice cubes, okay? Well, when we're looking at ice cores out in the world, what gets trapped in those bubbles is the air at that period of time when it froze. So when they're drilling these ice cores, and oftentimes they do go down a mile or two, they're pulling up air that is old. All right, this is time. Stuff on the bottom is older than the stuff on the top. You may or may not remember principle of superposition from earth science in high school, right? We use that for rocks. Well, the same idea works here. So this snow has to build up and build up and build up and build up. All right, so anywho, it is snow, but a glacier is ice. How do we get there? Well, living in Utica, this is, you know this, okay? I call them roof glaciers. When I first moved here, I almost killed myself with one of them, poking at it with a stick. We didn't have them in Ohio, I'll tell you that. That thing fell off, and it probably weighed about as much as I did. Luckily, 20 years ago, I had slightly more cat-like reflexes than I currently do. I was surprised, really surprised. We get them at the bottoms of our driveway, from the snowplow coming by, and then you guys having to shovel the driveways or snow blow the driveways, whatever. That's not snow sitting down there. After a good bit of time, that's ice. Okay? Again, when we first moved here, I was like, I'll shave off a little of that with the side of the van. Oh, that was a horrible noise. Horrible noise. I had no idea it was going to be so hard and icy. I should have known, but I didn't. Luckily, I didn't gouge it or anything like that, but it was not. My wife was very grumpy. But I was just trying to shake down, the edge a little bit. Because I still have that Ohio snowblower. I still do. The little paddles on it. I think the tiki beasts that you guys have here. And even if you've not somehow shoveled a driveway or know what I'm talking about, we've all packed a snowball a little too much and whacked our friend or little brother or sister in the head with it. And you knew maybe it was almost ice, but you didn't think it was that hard. It's the same idea. Okay? A little bit of heat from the sun melts it. The snowflakes lose their shape. Do we need to worry about all these vocabulary words? No. You're going to see fern. It actually says firm there. But we use the word fern, F-I-R-N, quite a bit for these little proto-ice pellets, snow pellets. So the edges come off the nice pretty snowflakes. Those compact down. And eventually it does just turn into ice. And it doesn't take, as I was pointing out, 130,000 years for that to happen. It could take a week. More of the same. Now we do have that word fern here. I wonder if that was a typo on the old slide. I don't know. But they do use the word fern quite a lot. Permafrost. Again, you've heard of permafrost around here. This would be the reason that, with one of your poor pets dies in the wintertime, we got to wait until spring to bury them. Goldfish goes in the freezer or whatever. And because, the ground is frozen. All right. Well, imagine if that ground never thawed. Again, there are places on the earth where that is, even if there's not snow, that the ground moisture is ice, and it just freezes that dirt together. So continuous versus discontinuous, the difference there is that it means it's spotty, okay? Probably elevation linked, but not necessarily. So this is current. Well, this is probably 30 years ago. It'd be interesting to see if it's changed. I don't know if anyone's updated this, but this picture's been around a long time. So what's interesting, or what sort of the point is looking at that dashed line down there in the United States there. And that's where the permafrost was during the last ice age, the most recent ice age. You see the Great Lakes there for reference. And you say, holy smokes, you may know, in fact, where the glaciers went to. It wasn't that far south. But yeah, in front of it was still pretty dang cold. Even though there wasn't a glacier there, it was still cold. Alpine permafrost, that is, again, current day, but up the tops of the mountain, where we say there's always, some snow. Well, there's always permafrost there, at least. Just showing how things have changed, and again, where they are now. More than likely, this discontinuous hasn't moved. It might move a little bit, but I'd be more willing to consider that the line for continuous versus discontinuous has edged back a bit. All right, so I told you we were going to talk a bit too much about how these things flow. Don't get too stressed yet. There's plenty of vocabulary words to worry about in this chapter you're not going to label this diagram ever, okay? But we want to show you that not only is it sliding down the slope, but there is the plastic zone there. It's sort of malleable, okay? That slime I was talking about. It's harder and thicker, obviously, but it flows in a similar way. They talk about plastic flow. But up near the top of it, because, the weather, it's much harder. It doesn't flow in that plastic way. So what you have is the bottom sort of slugging along, but the top is like a crust. It's stuck there, and it's going along for the ride. And because of that, oftentimes it'll crack. And you see the word crevasses there in the center. We're going to talk more later about crevasses. Those are nasty little things that eat hikers, and they're bad. If you're out there studying this stuff from an airplane, they're great because you can verify flow direction. It's going to bend and crack as it goes around a bend, so on and so forth. So you can tell the direction of flow from that, and if it's flowing, if the crevasses have increased or decreased, So they're useful in that manner, and that's why you see them there. But it's probably not going to apply to any of you guys. But you never know. You might go on some high adventure someday and find yourself hiking and on a glacier. You never know. So we'll talk about crevasses again a little later and why you need to be concerned about them. So a little bit more about flow here, but that is not the main reason I have this picture in here. I have this picture because this is a diagram you will need to label on the test. And there's at least half a dozen terms on it. So we're going to start up at the top. And again, scale is a big mountain. This could easily be a couple miles. Okay, not what it appears here. So up at the top, we've got zone of accumulation. What do you think happens there? Is that where the snow melts?
It accumulates.
It accumulates. Good. This is where it gets fed. All right, this is where it builds up. And as the name implies, for once, it's nice to have actual words that mean something. Zone of accumulation. So this is way up high on the mountain. This is where it's constantly snowing. This is where it's permanently snow, ice, whatever you want to call it. But as you go down a mountain it gets warmer, or more so, you probably know, as you go up a mountain, it gets colder. Well, the opposite is true, again, as well. You get warmer as you come down. So there's going to be a point at which you start to see more seasonality, what we consider seasonality. And we're going to skip over snowline for a minute, and we're going to go down to zone of ablation. I want you to call that zone of wastage, if you don't mind. Waste, and then just age on the end of it, wastage. You keep ablation in parentheses, but I'm almost positive on the test it's called zone of wastage. This is where the glacier is wasting away. So if I said this is where the glacier is ablating, you'll be like, it's whatting? Yeah, so we know what wastage means. So down here, this is seasonality. This is spring, summer, still ice there. Heck, I was just up north of Rome over the weekend. There's still snow in Ava, which isn't that far away from here, 45 minutes. There were still snowbanks. So this is where the glacier is wasting away. So in between that, remember I said we skip over snow line for a minute? This is the fern line. Not my term. And again, this says snow line. I apologize, but I'm telling you, please label it fern line. Remember, fern was that little snow pellets, those ice pellets. This is that zone where we see the changeover from the zone of accumulation to the zone of wastage. And it's not fixed, as you could imagine. This moves much like a water table might go up and down with heavy rains or a drought. So this is just an arbitrary line that marks the difference between seasonal snow and permanent snow. So zone of accumulation, fern line, zone of wastage. There's 3 points already on this diagram. I want to skip all the way down now to over here to the terminus. The terminus is the front bottom of the glacier. They say the glacial toe, all right, but terminus is a proper word. And then there's a handful of just random words on here that we'll see again later, but we'll introduce them because we're here. Calving and icebergs down on the left over here, top left, I suppose. We talked about this with Antarctica, how pieces of the ice sheet break off and float away, right? If this is over water or flowing into water, obviously the water is a bit warmer, or it wouldn't be water. And so that helps the ice break off, waste away, so to speak. But when it breaks off, that process is called calving. Calving. Birthing of a cow, okay? Birthing of a calf. I don't know if the noise sounded familiar or if just these little white things floating away. I don't know what gave it that name. But again, we had much of our early glacial geology coming from shepherds and whatnot, okay? They're out there in the fields, minding their sheep, and staring at the mountains. Early observationalists, as I like to call them. And their terminology, when the scientists went out and started studying this stuff, these are the people they came in contact with. A lot of that terminology sort of transferred over. So we keep some seemingly unscientific words every so often. So we see icebergs forming from calving. Sublimation. Who can remind us what sublimation was? It is. So that goes all the way back to our conversation about the water cycle, which we did have in here, right? We do hydrologic cycle? Pretty sure? Good. All right. And that is our phase change from ice to gas. We have melt going on. It's, it seems too simple to make that a phase change, but it is. Solid ice to liquid ice is a phase change. We call that melting. But a sublimation is going on as well. And that's that ice going directly to water vapor. What else is on here? Meltwater pool. Flow trajectory, we don't care about that either. Meltwater, you're going to see an awful lot about in the front of a glacier. The front of a glacier is essentially a wasteland. And maybe that's where the term zone of wastage came from. But there's so much sediment and stuff that these things pick up as they're sliding across the continents that when it does melt out, that sediment just gets randomly deposited. It's a mess. Huge mess. And all shapes and sizes. So here's another view of that. We got zone of accumulation, the snow line or fern line, the zone of ablation or zone of wastage, terminus. Okay. But here is what you're actually going to see on the test. A very high-tech 1999 Microsoft Paint image. So what would we call D? Just went through all these words. Zone of accumulation. Good. C is going to be, fern line. Good. Or the snow line, as the picture said. Again, I prefer fern. I think fern's what's on the test. B then is zone of the other zone, wastage, and then A must be that big toe up front. What do they call that? Terminus. Okay. So 1, 2, 3, 4. If this ends up being a 50-point test, which I try to keep my tests to, that's practically a letter grade. So it's a pretty easy diagram. Don't let this be, something that drops you from one grade almost to another. 4 points is a lot. Now, I will update, since I changed the PowerPoint, I will update this on D2L for you guys. For those of you that already printed it out, I apologize. Maybe you just print out the last couple pages. But so I will put an updated PowerPoint up for you guys. Okay, crevasses. So you see them around the ends here. For one thing, this can show us where the valley ends and the glacier starts. It can also, as I said, indicate flow. And if they're measuring, the width of them, it can tell you if flow is increasing or decreasing. Some neat stuff. But now imagine that you're one of those research scientists actually out there, and you set up camp for the night. And just like every cliche movie that you've ever seen that takes place in a big snowy field, you wake up the next morning, all your tents are covered in snow. It snowed like 2 feet the night before. You got to go out hiking in this stuff the next day. All those crevasses are covered up. And again, remember how sucky scale is on this, okay? Those are big pits, big ditches. And they are essentially walls of ice. So, again, when you see these people tied up together with one another, there's very good reason for that. Because you could be walking on 2 feet of fresh snow, too close to the edge. Even though yesterday you were studying the dang crevasses that were right there, you forget. You don't know where you are or how close you are. And those could be, 20, 30, 40 feet deep. And you ain't getting out. So never go hiking on a glacier alone. You guys understand? Good. All right. You think I'm nuts, but you never know where you'll end up. Go off work on your 4 years. Maybe you go on and get 2 more after that. Take you interesting places, and I hope it does. All right. In here, we didn't really talk about weathering and erosion. It's not a geology class, but you know that they exist. Weathering is the process that breaks rock down at the surface of the earth. Erosion is the process that transports the stuff you just broke down. Weathering creates sediment. Erosion moves sediment, right? You had this in earth science, however many years ago you had earth science. The things that do that, the forces that do that, wind, water, ice, and gravity. Those are our agents of weathering and erosion. This is background. Oh, you're not on a test, don't worry. wind, water, ice. Okay, so glaciers are one of the big agents of shaping the continent, all right, through weathering and erosion. We already mentioned the fact that it brings a whole bunch of sediment. We didn't use the word erosion, but around here, all the granite that you might find, be it pebbles on the ground or a giant rock in front of some office building, that came from Canada. We don't have granite around here. And some of those things are way too big to have, somebody paid money for and have trailer. Look, I'd like this giant 5-ton rock, please, in the front yard of our, no. That was when they were digging the foundation. They're like, holy crap, what are we going to do with this thing? All right, let's see if we can roll it up the hill. Good, it's where you like it. Good, it's staying there. That's where those come from. For the glacier, it was nothing. It melted out like, you dropped a quarter on the floor or something. It's no big deal. So this sediment comes down. You've driven the north from here maybe, and you're up and see those farmers' fields on the way up to Old Forge and whatnot. Rocks all over the place, okay? What are you going to do with them? Half the time they build walls, so on and so forth, fences, whatever you want to call it. But that stuff settles out, it shakes out of the rock. They get them with plows, and, they spend 30, 40, 50, 100 years, and you're still getting rocks. All that stuff melted out as the glaciers were coming back. That's all erosion and deposition. Weathering is that somewhere up north, those rocks were broken off of something else. Okay? Carried down here. The valley that I talked about in the beginning of the lecture, carved out. That's weathering. You guys have grown up more or less around the Finger Lakes. Probably heard that those used to be rivers or streams. Okay, now they're long, narrow, and very deep lakes. They were gouged out by the glaciers and clogged up. They no longer attached to Lake Ontario. So that's the kind of stuff that does weathering. Very specifically, we've got another diagram for you guys. I don't think this shows up as a diagram. It shows up more textually. We're going to be naming a handful of, we're going to show you another slide where the glacier's gone. The glaciers, plural, are gone. And we're going to be giving you some names for some features. So we go from this to that. Okay, glaciers melted, glaciers growing. And something to think about, okay, when the glaciers started, it's up here and grows down. When the glacier started, it's over here and came down, and so on and so forth. So they're going to start at the higher areas, they're going to grow and move down, merge together, so on and so forth. So what? 1, 2, 3, 4, 5, 6 more vocabulary words. Okay, this is why we change things like zone of ablation into zone of wastage. We don't have to guess so much what that word means. U-shaped valley. Told you already, glaciers tend to carve U-shaped valleys. They're just showing you one. Cirque. Let's skip 1 second to a picture to show you a cirque. A cirque is a steep-backed, bowl-shaped, a lot of hyphens here, steep-backed, bowl-shaped depression at the beginning of a glacier. So this is at the top of that mountain that we were looking at for a couple minutes ago in that diagram. All right. This is where the glacier starts, and it digs itself out here. Think about, I don't know, if you're getting ready to run somewhere and you've got your foot kind of pressed into the thing and you take off, you're going to leave a little imprint there. All right. Or if you're golfing and you're not so good and you take that little chunk of sod with your tee, all right. Same thing is happening here, except it's going on for thousands and thousands of years, and it just digs this out. Like a little scour pit, big scour pit. But it leaves a very unique sort of amphitheater-looking place. They showed you some of these out in some of the high peaks around here in the video we watched the other day. Until I saw that, I had no idea that we had I think Mount Marcy is one of the ones they name checked. There were cirques here. You always think of these over in Switzerland and all those traditionally cold places. But, anywhere you had the glaciers, you could have them. So that's you don't get that form any other way. So cirques, all right? So now we're going to take cirque, we're going to use that, and we're going to move to this center sort of spire where it says the word horn, all right? And what we basically have is a high point surrounded by cirques going down in all different directions, kind of like a wagon wheel, spokes on a wagon wheel coming off. So you get all these deep carves, and it leaves a rather high, pointy horn. Well, a high, pointy peak that they call a horn. And again, remember, I told you a lot of these words came from shepherds and whatnot. So we see some horns here. There's a rather famous horn. Anyone remember what that might be called?
Matterhorn?
Yeah, say it's a ride at the fair usually. The Matterhorn. Matter means mother. So the mother's horn, what would this? Okay, those lonely shepherds were staring at the mountains and picturing boobies. That's what Matterhorn is. Okay? Secret's out. But it's carved. Again, it doesn't look much different than any other mountain peak to you, but if you get down in there, you see these cirques around it to go back. Okay? And you see that, in fact, it is so steep because it was gouged out. Between the U-shaped glacial valleys started by cirques, we have something called an arete. A-R-R-E-T-E. That is a very steep ridge in between the glacial valleys. I'm told that arete, I'm pretty sure arete means stop, but we've always been told that arete, at least in some language, refers to like a knife or an edge or blade or something like that. And so I always went with that. But again, as we've gone through life and languages have become a little more commonplace, where's my arete? And there, look at that, there's a hiker on it. So this ridge going off into the screen there is a great example of an arete. He's already done the hard part, or at least he's walked on that one. There might be another one coming. But it would be a high point, a ridge that you would want to keep along. And again, the concern of sliding off either side, let alone watching out for crevasses once he gets back in the main ice. That at least should be solid rock. And we got hanging valley / truncated spur. So they're named over there, but it's much easier to see on the left side of the screen here, where another glacier comes through and cuts off some of these older valleys. All right. Again, it's just like, I hate to use it. I try to avoid using knife through butter, they always say. But it just, there's so much force, so much mass behind these things. They can carve through anything they want. And so it cuts off these old valleys. And we could even, I think I mentioned superposition a little while ago. We could get to a conversation of which glacier came first. All right, well, these guys, and then this one came through. We know that because these are all cut off. So at any rate, back to the last two vocabulary words. A hanging valley is left behind when one of these glacial valleys gets cut off. They quite frequently have pretty waterfalls in them, which is why we like them. These things are big ditches, big troughs. They're typically still rather moist environments, so they're going to get water flowing through them. Potentially there's still snow in the highest parts of these things. And then the spur is just that arete that's cut off. You see several spurs over here. They're just not labeled. And that's really just a function of having enough space to put the words in there. Now you're not going to see all these words, but I know Cirque and Horn, probably U-shaped valley, all show up. I think I had a hanging. Yeah, there's a hanging valley there. All right. So you have the glacial valley coming through that this waterfall resulted from, but then coming across this way, somebody just came along and sideswiped the whole thing, shaved it right off. Large portions of the world were not glaciated, at least in recent memory, enough that the features would still be around. So when geologists first started going norther and northerner to see some of this stuff, it was, it was amazing. Very confusing, I'm sure, to them. And that's, again, why we could talk to the locals, folks that have been there, and, we call this that. And it doesn't necessarily tell the geologist what it was or how it was formed, but then once we figured out what was going on, they often, times just honored those names. Almost done with the labeling diagrams. This one is definitely on there. Again, not as a diagram, but, no, it is. I can't remember. I don't think the diagram somehow carried over into D2L for some reason. It's just that question got mutilated and I had to retype them really quick. So you might see these textually. So we were talking about deposits a little while ago. All the sediment that melts out of these guys, it leaves interesting features or not so interesting features, depending on your point of view. But it leaves features nonetheless, and the geologist in charge of this stuff got to label those features. You know how it goes. So a moraine, which is what this diagram is all about, all the different types of moraines, are elongated piles of sediment, ridges of sediment, if you would. And they pile up either alongside of or in front of the glaciers, wherever you have an edge, because the edges are where you're going to get your melt, right? So we'll start with an easy one. Along the sides, we've got a lateral moraine. That's in the upper left-hand corner here, the left-hand side. And some of you were thinking, well, wait a minute, we've got some moraines in the middle there. And aren't those lateral moraines as well? Well, sort of. They're a special type of lateral moraine called a medial moraine. You see that word in the center top there. What happens when these guys merge? What was on the outside is no longer on the outside. Now it's in the middle. Median, like on the road. So medial moraine. And yes, you could have multiple medial moraines. It's all relative, it's all positioning. So again, a medial moraine is a type of lateral moraine. Right on the center of the diagram, really, where you see the glaciers from the right merging with the glaciers on the left. What was 10 feet back, a lateral moraine. Once they merge, it's now a medial moraine. That was the easy part. We got those two? All right. A moraine at the end of the glacier, very simply, is called an end moraine. However, we can't keep it that simple, because these things are constantly melting back or growing forward, but in this conversation, they're constantly melting back. So, much like any moraine on the side of a glacier is a lateral moraine, but then we had the subcategories. Any moraine in front of a glacier, at the end of it, is an end moraine. However, once you lay down moraines, once you lay down multiple end moraines, the farthest out, or the first end moraine, becomes the terminal moraine. Remember, terminus of the glacier is at the end. All right. So the terminal moraine at the moment marks the farthest that this glacier went. Any moraine behind the terminal moraine is a recessional moraine. It's receding. So in this case, you've got two recessional moraines behind your terminal moraine. You following me? Yes, they're all end moraines, but if there's more than one, you're not going to use that word. So a terminal moraine and a recessional moraine are types of end moraines, but if you call that an end moraine, I got to mark it wrong. The only time you would use end moraine, and you're going to see this in my carefully crafted diagram in a moment, is if there's only one at the end. Lastly, you see the word ground moraine. These things are only ridges or hills because it's sat in one place long enough to build up a pile. Okay? Sometimes the glaciers can recede so quickly that they don't really build up a ridge or a hill or anything. It's just a covering, sheet-like covering. That's what ground moraine is. So arguably a ground moraine would indicate a period of more rapid melting. So a ground moraine isn't a moraine after all, because we told you a moraine was a ridge of sediment. And this is not a ridge, it's a sheet. Isn't that lovely? I did not make these words up. So those are all types of end moraines, but you only use end moraine if there's one. Otherwise, you're going to use terminal and recessional. If it's not a moraine at all, but a sheet, you're going to say ground moraine. And if it's a lateral moraine in the middle, you're going to call it a medial. Get it? Got it? Good? It is pretty straightforward. In all honesty, you guys typically do, well, let me rephrase that. You either get these 100% or you don't have a clue on the test. So, again, talk about one, diagram being a letter grade. This is definitely one of them. Yet another piece of high art here. So we got two glaciers. We got Glacier A and Glacier B, the glacier on the left and glacier on the right. What would we call Z? We got a Z on the left and a Z on the right. Lateral moraine, good. How about W there in the middle? Yes, that's the medial. So two laterals came together. Now it's called a medial moraine. Beautiful. So I told you we'll look at the glacier on the right now. If you only have one moraine down at the end, we get to call that an end moraine. So T is an end moraine. Good. However, Glacier A is in motion. So what is S? Terminal. Beautiful. U? Oh, no, wait. No. X. X. I'm pointing. I want to see X. U's pointing to the dots. Recessional moraine. Now U. That's that ground moraine. Tried to make it look like a scattering of stuff there. No, that was, outwash would be in front even of that still. No, it's ground moraine. U is ground moraine. And this is multiple choice. You're not going to be doing fill-ins, so I think that helps, with coming up with the things. If this diagram is there, I got to look and see. Again, it might be textual. It might be textual. Now, application level question. What is Glacier A doing? Is it growing? Is it receding? What's it doing? staying the same. Based on the data you have there, you could say the Glacier A is what? Shrinking or is it growing, folks? Shrinking, good. Glacier B, probably shrinking. We have one end moraine, but for all you know, tomorrow it could plow that over and make a new one. Okay, we don't know for sure. So you can't really tell what B's doing. It looks like it's receding, probably receding, but we know for sure that A has been receding for a while. Anybody need any of those letters reiterated for them? Okey-dokey. Oh Lord, still half an hour to go. This is a really crummy picture. I should just delete this and make it 84 slides instead of 83 slides or whatever it is. 50. But I told you it was a mess in front of a glacier. This is a great example of a mess, and I think that's why I keep it in there. But it's totally not helpful for seeing moraines. This one, however, gives us a nice moraine to see. You got a little glacier here in the white thing in the middle, obviously. And these are two different times. Unfortunately, I did not capture the time. I don't even know if it was mentioned. We do have at least some citations on here. This is I've been using this for 25 years. This is probably the author of whatever McGraw-Hill textbook I took this from. May have worked for the survey, or they may have just borrowed this from the survey. But it is now lost to the annals of time how much time is taken between picture A and picture B. Picture B shows an obvious recession of the glacier. It's melted back. All right, and what that has exposed is what looks like a dead elephant seal there on the thing, but scale, again, hard to tell. That is a fairly substantial ridge. Okay, you see it in picture A here, and again, it might just look like carved rock too or whatever, but that is a pile of sediment. As the glacier recedes, you can see that even much more so that is that ridge or hill of sediment. The other thing that's kind of worth noting, it's kind of neat to see, is we have the beginnings of a dark spot here where we might have some melt going on. By the time we get to over here, boy, that hole sure has grown. So not only is it melting away down at the bottom, but it is melting in other spots as well. These are both in black and white, so this is obviously a long time ago. And now that I'm looking at it, I think the angle is, I don't know if the angle is slightly different or if there's just more rock exposed in the background too. Not quite, I never looked that far up. Like right here, it just looks different than, there's actually more rock here. I know it's just cropped slightly differently maybe. I'm sure that's what it is. Oh yeah, because there's no sky in the picture on the right. He couldn't stand in the exact same spot 20 years later. Yet an even better view of moraines. A lovely U-shaped valley in the background there. But see what I mean about how where it's vegetated and there's a stream and floodplains down there? It doesn't look like a U anymore. It doesn't look like a V either. But so a lot of this stuff is just totally lost, due to weather and erosion and time. But that is still very U-shaped in the background. This, I believe, is a wing crop here. I think this is somebody taking this picture out of a plane. Nowadays they would tap on that and it would disappear. So all this sediment we've been talking about has a vocabulary word as well. Imagine that. It's called till. T-I-L-L, till. And it's an unsorted mess of just all this sediment, rock fragments, whatever you want to call it, that melts out of the glaciers. That's what these moraines are made out of. It's a variety of shapes and sizes. Now, there is another vocabulary word that we're not using that you will see. You find some glacier information in your textbook. There is talk of glaciers in your textbook for the sorted stuff. Okay, and this is that happens when the water that starts melting out of it, it gets a good flow going. It'll pick up the sediment and sort it out, much like streams do nowadays. But yeah, so at any rate, this is all till, the stuff that's built, the moraines, the stuff that's washing out. We talked about the farmer's field. Oh, I can't say that word. That's all till. The giant boulder I mentioned, they do have a special name for that. It's called an erratic. And at this point, I can't remember what I said at 8 o'clock lecture versus this lecture. Like any of the big granite that you find around here. Did I say this 10 minutes ago about granite? Okay. Okay. So any of the granite that you find around here, we don't have granite here, at least at the surface. It was brought down from the glaciers, from Canada by the glaciers. And just dropped here, be it the small pebbles you might find, cobbles you might find around Lake Ontario, if you've ever been up there, to just random stuff in your yard, to the giant boulders, like I said, in some office complexes and whatnot. These things are just massive. Yes, sometimes people do pay for them, but they're so big, so heavy, they're very expensive. So oftentimes they are just found as you're going through the foundations. And yeah, I'm pretty sure I did just talk about that in some context. Oh, plucked. Plucking is an official glacial word. Plucking is the glacier kind of sucking those rocks, breaking them off of somewhere far, far away. They get absorbed into the glacier, kind of like the blob, and then travel along. Remember that traveling is erosion. And then as it gets further down, it melts out. That's deposition. Okay? So weathering, plucking, erosion, sliding down the hill, melting it out, deposition. Much like geology, environmental science brings in a lot of different sciences. How it applies them is what makes it, its concerns is what makes it environmental. There are so many different sciences in environmental. Which always makes us chuckle because you guys all register for environmental science because there's that urban legend that it's supposed to be easy. I don't want to take biology, that's hard. I don't want to. But we've been talking about biology for 3 months. Just in a slightly different setting. But it's all the sciences. Okay. I am going to stop here. Because this is where I started this morning, and I know how long it takes to get from here to the end. And that is the perfect amount of time to leave for Thursday. And your brains were stopped absorbing about 10 minutes ago, if not earlier. I don't think anybody came in after we talked about the tests. But if you have any questions, excuse me again, about our last test,